Namaste. Today I want to talk about another interesting innovation, a very significant innovation that NCST had introduced in the context of education. As we know, those particularly those who are working with computer science and IT fields, the key element of the key competence of anyone in the IT or CS field is the ability to do programming. Programming is, as I had mentioned earlier, it is not just about knowing the language syntax or knowing what is the meaning of a particular construct, but the ability to solve a problem. So programming as a means to do problem solving, which a computer can understand and execute, is the key to all IT and CS. And this was something that we were very interested in, and we wanted to make sure that in our education, this aspect was given enough importance. But how do we do that? How do we check that somebody can actually do problem solving correctly in the context of computer programming or in the information technology space? So, given a problem, they should be able to write a working program to meet that requirement. So this actually calls for multiple aspects, which is usually not a part of any curriculum. So first of all, when I give you a problem statement, it will not be usually just the requirement that you have. It will have some extraneous information. It will have information which may not be very relevant to you. Something which may have to be processed and understood to make it relevant to your requirement and all that. So this is the key element of learning abstraction. Now, all programming books will actually talk to you about abstraction, and there are lectures about abstraction. But the key part of abstraction is that when given a problem statement, you are able to understand what is relevant, what are the key parameters here, how are the parameters related to other aspects. So this information has to be suitably structured and extracted, and that is the key element of designing the solution. Because once you understood these parameters, then suitable algorithms and data structures and all that can actually be identified. The failure is usually in not picking up the right information, or sometimes picking up information which is not required, and then it might complicate the design. The second part of it is when you are designing the solution, what are the boundaries of that input? About the boundaries of the input that is sought in the problem statement. So if it is numbers, what is the largest number, what is the smallest number, are negative numbers counted, can fractions come, can floating point numbers come, what is the precision, and again negative numbers are valid. So a lot of these aspects are to scoping the input so that your program will work across the desired input region is important. So identifying the boundary values up to which you should be able to, your program should work, is one another key ingredient of doing such computational problem solving. And the third element is the ability to debug a program. Now, most of the time, I have seen that people actually write a program, and as usually is the case, it won't work for all the inputs that is expected, and then you just throw it away and then rewrite the program all over again. This is not a workable strategy for actual problem solving applications. So, given some draft program which is able to do something, how do I identify what are the weaknesses? How do I fix those problems so that those weaknesses are resolved? Is what debugging was all about. This is something that most students, even many of the young professionals are very weak at. And therefore, when a problem is identified, it can take an arbitrary amount of time to figure out what is wrong. Often it just simply resorts to trial and error. So what are the good ways to debug a program? What should I do when I'm writing a program so that my debugging time is well spent, or my minimal amount of debugging time is required? That When a problem is identified, I can quickly narrow down as to what could be the source of that problem. So these three elements is what actually moves from programming as learning a language to programming as problem solving is all about. And that is what the designers of our courses actually wanted to do. So even before I got into it, there was an idea created that we can actually give them a problem statement, ask the student to understand it, write a program, and submit it to some automation system, and the system would evaluate that program. Now this is a big challenge, right? If you give me a program which might work, evaluating the program as to whether it is correct and complete and all that is a much harder problem, because ideally I should actually look at the source code, look at your design, look at your data structures and all that. So this was particularly in those days of late 80s, early 90s and all that, this was a very hard problem. And therefore, a pragmatic approach was taken, saying that, okay, if your program is actually working, then if I throw in any valid input, it should produce the desired output. How do I get the desired output? These were also challenges, because if you hard code the outputs, and then there are possibilities of error when you change the input, or when maybe some assumption that you haven't actually taken into account, all that can create discrepancies. So the idea was that, given a problem statement, a qualified faculty member would actually write the similar program as what we expecting the student to write, and assuming that the faculty program is correct, which itself is a process. We do multiple levels of reviews and guinea pigging and all that to ensure that the faculty program is actually correct and adheres to the specification that is given. Given a same input to the faculty program and to the student program, it should produce the same output. So this gives you a lot of flexibility, because I can add more input cases dynamically, and as long as it is within the valid specification, it should actually, this approach should work. And so a whole methodology actually had to be evolved to make this whole process effective. I'll talk about that in maybe part 2 of this series on what. So this whole thing is called the machine graded programming test. That is a programming test which is graded by machine. mgpt is the nickname that we have coined, and it became very popular among students. So mgpt evolved to be something of a phenomenon by itself, because there were stories written about it, there were skits performed on mgpt, and even poems written on it. Okay, this was used to happen in those days. So the methodology that we created is very detailed, documented in a T4E, Technology for Education conference, which was held in IIT a few years back. A few of us actually authored that paper. So that actually details it. I'll talk about it in another session. And why mgpt became a phenomena is because this combination of abstraction to design, boundary cases and debugging is something that is very hard to teach. So it need to be learned by practice, and evaluation, as I said, is very hard, because manually evaluating these kind of things is very, very tedious. So we needed an automated system was required to do, which is what we ventured to do. And this was the system which is now called the parikshak, which started as just a bunch of shell scripts which would just run this student program and the faculty program, given an input, pick up the output and compare, and then come back and say how many of your input cases actually it worked. And from there it went to standard C programming running on Unix. And today we have a very comprehensive web-based program solution called Parikshak, which is available from CEDAC Mumbai today. So this is actually a very solid and very necessary ingredient for any IT or computer science professional, because First of all, we should recognize that programming is not about learning a language or the nuances of a language, but programming's purpose is to solve problems. Okay, and that is what MGPT actually drives for. And I'll continue this thread in my part two of this, where I'll tell you more details of the methodology and how that whole system got evolved, and some interesting stories about how parikshak was influenced or seen by students as well as potential recruiters. Take care. All the best. Thank you.